This video is a very brief introduction to balancing chemical equations. Why do we need to balance it? It looks like we can just see the equation and see what stuff we have on the left and what stuff we have on the right. So let's do this table first. We're going to make a table of how many atoms of each element there are on the left side and on the right side, and we'll see why we need to do some balancing. On the left side, looking over here, and I labeled this R for reactants, we have 3 carbons, we have 8 hydrogens, and we have 2 oxygens. On the right side, the product side, we have 1 carbon, we have 2 oxygens plus 1 more is 3 oxygens, and we have just those 2 hydrogens. So what is an equation? An equation is a representation of things being equal, that's the equal part in equation, things being equal on both sides. We know this in math, and it's also true in chemistry. It's an equation if the stuff on the left is equal to the stuff on the right. Well, we can clearly see here that's not the case. There's more carbons on the left side, there's more oxygens on the right side. Clearly these are not the same thing on both sides. And so we need to balance this equation so that we have the same amount of each element on the left side, the reactant side, as we do on the right side, the product side. And these are the 3 basic steps that we're going to follow. What we're going to do is adjust the number of molecules of each substance so that we end up with the same number of atoms of each element on one side as we do on the other. So to be clear, we are going to be putting in coefficients in front of the molecules. Because if we were to change numbers like that, or that, or that, we would end up with very different things. Now, for example, let's look at carbon. We're going to look at carbon first because of this first guideline that says stuff with other stuff. What on earth does that mean? It means that the elements that we're going to try to balance first are the ones that are always mixed up with other things. In this case, carbon, on the left side, it's with hydrogen. On the right side, it's with oxygen. It's never by itself. Those are the kind of elements that we're going to start with. On the left side, there's 3 carbons. On the right side, there's 1. We clearly need 3 times as many. So we're going to put, in front of CO2, we're going to put 3. Again, just to emphasize here, if we did this, I don't know if that exists, but if it does, it's something very different from carbon dioxide. So we're not going to do that. We're going to put in a coefficient. Every time we put in a coefficient, we change how many atoms of each of these elements there are. So we now have 3 carbons. So I'll change this one to 3. We also changed the number of oxygens. There's now 6 there, 7 oxygens. And we did not change the number of hydrogen. Okay, better, because now at least the carbons are balanced, but the other 2 are not. You notice this third step that says anything alone. What that refers to is that if we get everything else balanced, we can change the number, in this case, of oxygens without affecting anything else. So we're going to save those until last. We're going to save anything that's by itself until last because we can adjust it without messing up anything else. So in this case, second, we're going to do hydrogens. Why didn't we do hydrogens first? Well, hydrogens, and in particular waters, as you can see in step 2, they just have a way of working out. If you have waters, leave them until later. So we did the carbons, now we're going to do hydrogen. We can see what we need. We need 4 times as much hydrogen on the right side. So again, I'm going to put in a coefficient of 4 here, and that means again we need to adjust our numbers on the right side. We only changed this molecule, we changed the number of molecules of this. So no need to change the carbon number, that's set. We now have 8 hydrogens, and we also changed the number of oxygens. We still have 6 over here, we now have 4 over here, that's 10. Now you can see why we saved oxygen, the one that's alone, until last. Because now we can just change the number of oxygens on the left side, and I'll go ahead and put that 5 there. since we need 5 times as much oxygen as we have. And when we do that, we're not messing with the carbons and the hydrogens that we just worked hard to balance. Well, not that hard, but we did it. And so now all that's changing is the oxygen, and all of the elements are balanced. And again, the way we did that was we started with elements that were always bound up with other things. In this case, carbon was never by itself, it was always with other things. We saved H2O for second because you'll see as you do more of these, waters just kind of have a way of working out. So we never do those first. And then definitely what we saved for last was anything that's by itself, like oxygen here, because we can change it, as we did in our last step, without affecting anything else.